Hello friends, this video on DNF block elements part 30 is brought to you by examfear.com. No more fear from exam. Let's talk about some of the important compounds of D block element. The first is oxides and oxoanions of metals. See, oxides are formed when you react metal with oxygen at high temperature. All metals except scandium, Sc, they form oxides. Except Sc, scandium, all this metal form metal oxides. Right, and all these metal oxides are typically ionic. We have seen that most of these are ionic, and highest oxidation states are shown by these oxides. Why? Because this oxygen has high electronegativity. So this, for example, Fe2O3 oxidation state is +3, Mn2O7 oxidation state is +7. So high oxidation states are shown by these oxides. And also, as oxidation number increases for these oxides, so oxidation number of transition metal is directly proportional to the ionic character. Sorry, it's inversely proportional to the ionic character. Right? So oxidation number increase, the ionic character decrease, the covalent character increase, and also the acidic character increase. Okay? So oxidation number of oxidation state of transition metal is directly proportional to the covalent character and is directly proportional to acidic behavior. So we have seen higher oxidation states acidic. For example, Mn2O7 is acidic, MnO2 is basic. Okay, these things we have seen. Acidic oxide, we have seen a lot of acidic oxide. For example, V2O5 is acidic oxide, CrO3 is acidic oxide, Mn2O7 is acidic oxide. In all these, the oxidation states are pretty high. If we talk about basic oxides, we have oxidation state pretty low. For example, MnO, FeO, right, +2, or VO, +2. These are NiO, also +2. Talk about amphoteric oxide. Amphoteric oxide are they have not very high, not very low oxidation number. For example, MnO2 +4, VO2 +4, right? CuO is +2. So these are the ones which are amphoteric. Okay. The next important compound is potassium dichromate, K2Cr2O7. This compound, you must have used this compound in your lab. It is used in the leather industry. It is also used as oxidant in the preparation of many ozo compounds. It is prepared from chromate, and chromate comes from chromite ores. So let's see the preparation of this. We'll take this chromite ore, FeCr2O4. This is chromite ore. This is chromite ore. From this, what we do is we react with Na2CO3 and oxygen. I write a balanced equation. What you get is Na2CrO4 and Fe2O3 and carbon dioxide. This is what you get. Okay, and this is yellow in color. So once you get Na2CrO4, you filter this and you acidify this with sulfuric acid, right? So you add H+ to it. So what you get is Na2Cr2O7, right? This is called sodium dichromate. So once you have sodium dichromate, and also you get Na+ ions and water. Okay, so once you have this sodium dichromate, actually you react this sodium dichromate with KCl. See, sodium dichromate actually is more soluble in KCl. So what you get is potassium chloride. When you react, you get K2Cr2O7 and sodium chloride. This is orange crystal. Okay, so this orange crystal of potassium dichromate crystallize out and you get this potassium dichromate. Okay, please note this chromates and dichromates are inconvertible in the aqueous solution depending on the pH of the solution. For example, I have this CrO4 minus and make it acidic, it becomes Cr2O7 and water. Okay, same thing if I have Cr2O7 minus to this one, you have this basic solution, it becomes CrO4 2 minus and water. These are interconvertible. Okay, so CrO4 minus 2 and Cr2O7 minus 2, these are interconvertible. We see CrO4 minus 2 we added this H plus, made it acidic, and we got Cr2O7 minus 2. Okay, so we talk about the structure of CrO4 minus 2. This is the one. This is tetrahedral. And if you talk about the structure of dichromate, this one Cr2O7 minus 2. This is again two tetrahedral. They are two tetrahedral. This is the structure. This angle is 126 degree, 179 picometer is the bond length, and this angle, chromium and oxygen, this bond length is 163 picometer. Okay, so this potassium dichromate actually is a very strong oxidizing agent, and this is actually used as a strong oxidizing agent in the industry. For example, K2, or let me give this one example, Cr2O7 2 minus. Actually, if you see, you react with acid and it takes this electron and it becomes 2RCr3 plus, and it gives some water molecules. If you see, plus 7 oxidation state becomes plus 3, it gets reduced, and thus it is a good oxidizing agent. Okay, the next important compound is for D block is potassium permanganate, KMnO4, very important compound. This is prepared by fusion of MnO2 with alkali metal hydroxide and oxidizing agent with KNO3. So you see, I have MnO2 with alkali metal hydroxide, that is potassium hydroxide, for example, potassium hydroxide and oxygen, you get 2K2MnO4 plus water molecules, and this is actually dark green. Okay, now this dark green MnO4 2 minus, whatever you got, this is actually, we see dark green MnO4 2 minus, right? This dark green, actually when you acidify this, you get MnO4, KMnO4, and you get MnO2, right? And you get some water molecules. So MnO4 2 minus, this is MnO4 2 minus actually, when you acidify it becomes MnO4 minus. Okay, this is permanganate. Okay, so if we talk about the commercial preparation of this, what we do is we take alkaline oxidative fusion of Mn2, and that is being followed by electrolytic oxidation of manganate ions. See, you get MnO2, you fuse this with KOH and oxidize by air, you get manganate ion, MnO4 2 minus, this is manganate ion, and this is permanganate ion. Okay, so once you get this, you do electrolytic oxidation, and this is done in alkaline solution. Alkaline solution. So what you get is permanganate ion. MnO4 minus is permanganate ion, MnO4 2 minus is manganate ion, and manganate ion is green in color, dark green, and permanganate ion is dark blue in color. And if you see the structure of these manganate ions and permanganate ions, both are tetrahedral. And actually you can convert these, they are also interconvertible. For example, I take KMnO4 manganate ions and I heat this, you get K2MnO4. A permanganate ion becomes manganate ion and MnO2 and oxygen. This is the balance reaction. So KMnO4 permanganate can actually be converted into magnet. Okay, so MnO4 2 minus, this is green tetrahedral paramagnetic, it's paramagnetic, and this is dark purple tetrahedral, this is also paramagnetic. The only difference in the color. Okay, and this is actually uses good oxidizing agent. Acidified KMnO4 solution, it can oxidize oxalates to carbon dioxide. So if I have oxalates, it can be oxidized to carbon dioxide. It can oxidize Fe2 plus to Fe3 plus. It can oxidize iodine to I2. All these are done by acidified. You must have seen this term acidified KMnO4, very, very strong oxidizing agent. Now why acidified? See, if you talk about acidified, acidified means what? H plus, right? So if you talk about MnO4 minus ion, okay, so this will take one electron and it will become MnO4 2 minus ion. We have seen this. Now this MnO4 minus ion, in presence of H plus, it will take 3 electrons and becomes MnO2 and 2H2O. The same MnO4 minus ion, if you see, in the presence of more acid, 8H plus, it will take 5 electron and become Mn2 plus 4H2. See, the role of MnO4 is oxidizing agent, right? So in this case, it is getting reduced from +7 to +6. In this case, from +7 to +4, little bit of acidic. More acidic, +7 to +2, highly reduction. If it reduce from +7 to +2, then it will oxidize something more, correct? So more acidic is the medium, more is the oxidizing power of KMnO4, and that's why we use the term acidified KMnO4. Without acidic medium, MnO4, KMnO4, potassium permanganate is not that strong oxidizing agent, but in place of acidic medium, it is a strong oxidizing agent. Now we'll take some reactions where acidified KMnO4, actually I'll use this word now, acidified, because we have seen that in case of acidic medium, this reacts better. I told you iodine, it will oxidize that, so you'll take MnO4 minus and we'll take acidified medium, so it will form Mn2 plus, water and iodine gas. You can actually balance this. This is 2, this is 16H plus, and this is 2, this is 8, and this is 5 iodine. Same thing, iron also. You have iron Fe2 plus in the presence of MnO4 minus, again acidic medium. It will oxidize, it will get reduced itself and oxidize iron to 2 plus to iron 3 plus, and this guy is yellow in color actually, and this Fe2 plus is green in color. Okay, oxalate ions also, it can actually oxidize CO minus, actually I have shown that CO minus, and you use again MnO4 minus, we use some acidic medium to make it better oxidizing agent. You get Mn2 plus and some water molecule, and this comes out as carbon dioxide. This is the reaction. Okay, similarly, in fact, hydrogen sulfide is also oxidized, again MnO4 minus. This is more strong in case of acidic medium, so we'll add some acidic medium, it becomes Mn2 plus and some water molecule comes out and you get sulfur back. Okay, in fact, sulfite is also oxidized to sulfate, SO3 2 minus, when you have MnO4 minus as oxidizing agent in presence of acidic medium, you get Mn2 plus some water molecule and you get SO4 2 minus. So you see, it oxidizes so many things. Even nitrite can be oxidized to nitrate, NO2 minus, in the presence of 2MnO4 minus and some acidic medium. You'll see that it becomes Mn2 plus and NO3 minus and what? So here also if you see, all these things are getting oxidized. But this is happening in the presence of acidified KMnO4. What if we have little alkaline or neutral KMnO4? Let's see that. So now we have alkaline or neutral. It's a little alkaline or neutral. So let's see iodide. Iodine, if you see I minus was being oxidized to I2. But here in cases of acidic medium we just saw. But if it is not acidic, and let's see the reaction, just water, a neutral medium. So it becomes MnO2 and it gives 2 OH minus and you get iO3 minus. You talk about thiosulfide, it is oxidized to sulfate, S2O3 2 minus. You react with 8MnO4 minus and some water molecules, right? It becomes MnO2 and SO4 2 minus and OH minus. Same thing with manganese salt, they are oxidized to MnO2. So I have MnO4 minus with manganese salt and some water molecule. It will all get oxidized to MnO2 and carbon. So this is the balanced reaction. So thus we see that KMnO4 is strong oxidizing agent in case of acidic medium. Talk about the uses of KMnO4. As we have discussed, oxidizing agent, so it is used as oxidant in organic chemistry, most popular oxidant in organic chemistry. It is used to bleach what? Bleach wool, cotton, silk. It is also used for decolorization of oil. You want to decolorize oil, then this KMnO4 is used there also. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.